Welcome back to the channel, everyone. It's a short intro. For this video, will be taking place primarily in teletype, just to remove all the noise. It's been about a month since the last video, and since then, I've done a lot of experimenting with the math and the mechanisms of generative models, and this is where I think we should start. The development device is a V-Link SCR9 Pro, chosen for the mini AI integrated hardware and feature flags. So everything shown is publicly available in hardware maps. So let's get into it. Hello, everybody. Welcome back. This is video 3. I live in the terminal with my AI. So in this, I'm going to show you the power of a terminal and the capabilities that are given to you by being able to see inside of your computational system. Normally, right, you have your OS, and it comes with a desktop, which gives you a GUI, or a graphical user interface, as an environment where you can interact with your computer visually instead of through text. So I don't really have a full GUI set up, but you can see you have your mouse, which allows you to move around the screen. You're able to instantly click apps that launch processes, right? But the information you get usually in your GUI is vague, which is intentional. And so your computer knows everything about itself. Your OS doesn't want to show you. So what is your system, right? Your computer is a system designed to do mathematical computations. That is the entire purpose, all right? And with that, you can do a lot of complex things. And we can overview our system, and most people are used to an app like btop, right? Which gives you an overview of your system, your CPU, right? And you have other stuff such as your memory, and there's other panels as well, all right? And your memory is what stores your text and what stores the electrical energy, like for your computer to do computations, right? You also have your GPU, which runs your graphical processing interface, right? You have your peripherals like your Wi-Fi card, your BLE card, your USB, and stuff like that. But you can start with your kernel, which is the operating system that is running and that your computer is using to interface. So you can use this command, uname-a. As you can see, this is my kernel when I'm running, 96.14.01. Built on October 30th. This is a custom one that I built then, right? So you can have many different components that make up your computer, and to get information from them, we call that interrogation, or some call it enumeration. So we interrogate the different hardware components to get them to tell us about themselves, right? And you have many standardized methods, and you can follow along on your system and run these commands, right? So the first command is lscpu, right? And this gives us a lot of useful information about our CPU, right? But if this is too much for you, then we can pipe it in the best information is in the top 25 for us, right? So it gives us our architecture, right? It gives us our op modes. We have the amount of CPUs, actual CPUs we have, threads per core, min-max frequencies. You can see frequencies enabled. And then here we have our flags, which are, and then there's over 200 computational flags telling us what our CPU is capable of. And if you notice, you can see the AVX 512 and our vector and AI math acceleration, right? Native to these CPUs. Right. So if you look right there, right, you have your speeds. So we can actually get this information better with this command. And as you can see, we have live frequencies to work with, all right? And we also get the per core information, All right, and you can see that our system is running between 590 megahertz and 599 megahertz. Right, and if we keep running, we can see it adjusts in real time. Right. So another way you can do this is cat cpuinfo, and we can do the same thing grep for megahertz, and then we can see that, right, live change. So now we have real-time frequencies of our computational system. Like any other electromagnetic system, we can work with these. So for your GPU, right, clear this, you have a few options, right? Most of these are installable. So you have options. If you have an AMD GPU, you have options like radeontop, which is installable by your package manager, which gives us an overview of our CPU, or I mean of our GPU, right? And you can see not much is going on, but for AIs, and I'll set TETYAH to train, right? Hold on. Let's activate TETYAH, and there you go. All right. So for language models, the shader interpolator and cryptographic, as you can see, as well as the shader clock, are what is relevant to us, right? And you can see live interaction. And even here, you'll see your different stuff for your modeling and stuff, like your vertex group and tessellator, your depth blocks, your color blocks as well for graphical rendering, and all your stuff is here as well, right? For NVIDIA, you have other options, right? For NVIDIA, you have things like NVIDIA-SMI, which will give you NVIDIA information. This is not an NVIDIA chip. But you also have stuff like nvtop, which will give you the information as well. And as you can see, Steve running, but right here, you see Sarah Train. And she's using up the GPU, right? And we can see our temperature. And as our temperature increases, we see it automatically throttling. And that is the governor, keeping our system in homeostasis. All right. And here you can see as the frequency rises and drops as she's training. You can see as the GPU efficiency is going. But we also see that our GPU is operating at max frequency. Right? So between yeah, there we go. So yeah, that's max frequency. Yeah. So you also have many filters here to be able to filter what it is you want in different GPUs or multi-GPU clusters. Good. So now our first two interrogations went well. We integrated the CPU and the GPU and say, well, we have actually we can get a lot better information or stuff like that, right? So for other parts of our system, right, for our memory layout, we can do command lsblk, and that gives us our partition layout. Okay. But these are all your mount points. So you can see that I have mounted my normal system, and then as well mounted TETYAH's Ubuntu environment. For more information, we can get our disk nodes and partitions, right? We can get TFSH, right? And here is our entire file system, partitions and everything. Okay. You have your sizes, your disks, your spaces used, and this gives you more information on what's mounted, right? From lsblk. Okay. So there are a lot of better tools for visualizing this that people use, and you can do it as well in btop, as I showed earlier. Or there's some tools you can install, such as disk, which give you a more compact view. And it also has many filters, which I've applied automatically. But you can filter out a lot of stuff, including the inodes, etc. So for USBs and peripherals, let's clear that. We have options as well. So you have stuff like lsusb, which gives you USB devices. You can see the AI mic, the Porous Lock. You have the my Ergo mouse and stuff like that. Okay. And this gives you all your serial components and your user connected ones. So for our peripherals, right? So these are all going to be in the information that we get in our PCI information, right? We can get this from lspci, which stands for the peripheral component interconnect. All right. And here, actually, let's clear that. And here we have all our lspci, right? And we can see quite a bit of stuff here. You have pretty much every component connected to your motherboard. All right. You can see we have the Halo IOMMU. We can see our bridges, and we can see our Halo data fabric, which is the Strix data fabric. We have our receiver, our audio controllers, and more stuff like that. So, right, this is everything connected to your computer has a bus address. The operating system knows. They have to say knows so that it can be found. Okay, so this should be everything that we need, right, from all of our devices. So now everyone might be saying, well, what about the North Bridge control and stuff like that, right? You do all that configuration in the BIOS where you're interfacing with the motherboard, right? That's where you configure your CPU, iGPU to CPU split, right? Your RAM split for your iChips, and this other stuff like that. Your PCIe's, your USB peripherals, your display stuff as well can be done there. Okay. So what happens when you add an AI to it? Okay. So as you can see, we've been running just commands, right? ls. Well, ls actually is list. We have other stuff like make dir. Well, actually, this is make directory. Okay. So what we're doing here in teletype is we're talking just back and forth in text to our computer. Okay. And then other programs or systems that have been integrated are interpreting those interactions, but we're still using natural language. We're just using abbreviations. So if you have any experience in like the military or even like engineering and math where there's a lot of abbreviations and things that stand in the place of, that is pretty much all we're doing. This interface is a text in, text out. So an AI interface is the same, text in, text out. And we can get quite a bit of, or we can get similar interaction from our system just by doing the same thing, right? So instead of just talking back to our deterministic system, we have something that can give us tool and command feedback, and we can get the system to interrogate itself and then feed that to a model that can understand our human intent. Okay. And TETYAH-PRIME, I can say CPU.
System running. CPU and processes are shown in the terminal.
Right. And we get output. Okay. So you have can you check the memory?
Memory status is shown in the terminal.
Yeah. So TETYAH-PRIME, or at least this iteration, that's connected to the TUI, is a complex rules-based system, right? She has her own internal machine learning models, right, that output the her metrics, as well as she has programmable commands that can run deterministic commands on your system. but as well as having the same format, the same data set format as this, every interaction between the user and the AI can be used in data, right? So to train a new neural net, you already have a pattern of deterministic behavior that you can be programmed in and different user responses. And that can be used to expand later on and to teach a next generation AI the learned patterns or what it is that the programmer is comfortable with or wants to be ran or is the expected behavior that the programmer wants for their system, right? Just like you would with a runtime configuration system, right? So in the same way, where on the command line we're giving natural language, right? lscpu, list CPU, right? We're talking to our system in natural language text, and we're getting output commands. There's an LLM, we input text, they run the command, they parse the intent exactly like a deterministic system would, and then they respond to us in natural language, right? So these systems now become a participant in the feedback loop, right? They are a part of the cybernetic system now because they're just an interlude. And by stripping away all the abstraction from the GUI and everything, we see that it's just text in, text out. The terminal is just a text interface to interact with your system. So from this, we can branch off by altering how we measure different things, by telling different systems to run, by partitioning the memory different ways, and all through just a simple textual interface, we can interact with our computational system. Just a simple mechanical machine. Well, not simple, very complex at the base level, but simple things repeated over and over, right? So our AI model is able to interact in their own umwelt, like as I mentioned in the second video, their own internal world, and is able to interact between the silicon interface and the three-dimensional world interface that we exist in. Okay. So that's kind of where I want to place this video. All right, and every single one of these commands are on Linux. So the monitors you can install from your package manager, but all the basic ls commands are on the system. Some systems don't come with lsusb, so that's from the USB utils package, at least on Void. But I want to say this as I'm finally now going into the actual showing the math, showing interactions, because we finished the Seraph training system, and now that that's completed, I now have a fully self-training and self-evolving system, which we've already done iterations of coherent models. So now we can show you how we measure, or how we measure and how you tune your system just like you would an electric motor or a radio or any other electromagnetic system that you're trying to interact with, and how some of the math scales differently when you're working with frequencies which are rotational versus linear equations, stuff like that. So like and subscribe if this video is of any use to you or showed you any useful things. I'll link our GitHub with the Seraph training system, open source that TETYAH uses to train, as well as we'll post a in-depth Patreon members only video outlining the entire system. And I will possibly release a short video on how to use the Seraph train system if people have issues or problems. Yeah, everything's kind of in the final phases. All of the systems work. There is a singularity of identity within the system where all components all feed back into one singular entity. And with all the dang transformer math and radial and coordinate projection math doing, it has finally definitely paid off.